Okay, so today's topic is acid-base pH, and we will talk about buffer in the next unit lecture. And today our focus is inorganic molecule. So any molecule, they do not have carbon nor hydrogen. So you should have two. That's inorganic molecule. And there are some exceptions. So CO2 is inorganic, but it only has carbon. It does not have hydrogen. So if it's organic, you need to have hydrogen and carbon. And if you have miss one of them, it's inorganic. And they usually use ionic bond or sometimes covalent bond. And these are the examples of inorganic molecules. Usually they're small. They're small. And for organic molecules, we will have a separate lecture talk about organic. Their molecules have carbon and hydrogen. You need to have both carbon and hydrogen. And they're large. They're large. Usually they're bigger than the inorganic. They use covalent bond to connect together. We will specifically talk about these four biomolecules. They are the organic molecule found in the human body: carbohydrate, proteins, lipid, and nucleic acids. Okay, so today's main topic is inorganic molecule, especially the acid and the base. So certain molecules, when they put into water, and that they can become acid or become base. So for water itself, they will dissociate and become ion. Like water, it can break its covalent bond, become hydrogen ion and OH ion. They're ions. But in this case, when they break, okay, break one water, become one H plus and one OH negative, 1 and 1. So this one has positive charge, this one has negative charge, and they're balanced. So for a water, it's neutral. But in certain situation, you can have more H plus, like you add HCl, hydrochloric acid, and it will break the covalent bond, become the hydrogen and chloride, and now you have more H plus in this water. And we call this solution acid. So acid is you increase the concentration of hydrogen. That's acid. Then what's base? Base, we have two definitions. The old definition is you have more OH. You have more OH. Like you add NaOH into the solution, and now they have more OH. That's the old definition. And then the textbook, they want to define everything by hydrogen. So they defined the base about 10 years ago. They changed the definition. They say base is they can decrease the hydrogen concentration. So when the solution is more basic, they have more OH. And when you add H plus, then of course, H plus and OH combine become water. And that's how you decrease the H plus. So both definitions are correct. Base is they either have more OH negative or they have the more bigger power, decrease the concentration of H plus. Or you say the solution have less H plus is base. So that's the acid and the base. So acid has more OH, acid has more H plus, and the base has more OH negative, or base have less H plus. You have more OH negative, you have less H plus. And we want to put a scale, we want to use a scale to measure how acidic or how basic the solution is. And it come up with the pH scale. So that's the main point for this lecture. So pH scale. And pH scale come from 0 to 14. 7 is neutral. So if the solution is pH is from 0 to 7 is acidic. And acidic means more H plus. If the solution's pH is from 7 to 14, we call it basic. And basic has more OH or less H plus. And that's the pH scale. You can have every solutions, you measure it, it will give you a number. That's the pH scale. Like the Coke pH is 2.5. They are very acidic. Water pH is 7, is neutral, or bleach is basic. The pH is higher than 7, is about 10. That's the bleach pH, 10, 11. So that's the pH scale. So first thing you need to know about the pH scale is if the solution is more acidic, the number pH scale will be smaller. And it's more basic, it will be bigger. So that's the first. Second, in the pH scale, every time you change the number by 1, and it's 10 times more hydrogen concentration because it's a log scale. It's a log scale, so it's based on 10. For example, I have two solutions. Solution A, solution B, pH 5, pH 6. So I can ask you which one is more acidic. And you know, okay, solution A is more acidic because the number is smaller. Second, I ask you how much more H plus in solution A than B. The answer would be 10. 10 times more. I can ask you both. I can ask you more or less, or I can ask you how many times more. And why the reason is 10 times more? Because, well, the difference of these two in pH scale is 1. And it's a log scale. So every time in a log scale, the difference is 1, is 10 times. Okay, one more practice. This time I have two solutions. Solution A, pH 9. Solution B, pH 8. So which one is more acidic? B, right? B is more acidic. So we can say solution A has less hydrogen than B because it's more basic. Or I can say solution A is more basic. And then how many times less hydrogen in solution A than B? The answer is 10. So pH scale, every time you change 1, the difference is 10. Okay, how about this? I have two solutions. Solution A, pH is 8. Solution B, pH is 6. Okay, which one is more acidic? B, right? And which one is more basic? A. And which one has more hydrogen? B. Which one has less hydrogen? A. Okay, that's how we define the pH. And the last question, how many times more hydrogen in solution B than A? The answer is 100. The answer is 100 because the difference of these two, 8 minus 6, 2. So the difference is 2. So it's 10 multiplies 10, totally 100 times. So solution A has 100 times less hydrogen than B. Or you can say solution B has 100 times more hydrogen than A. The difference is 10. So it's a log scale. 10 multiplies 10 is 100. Okay, one more practice. Solution A, pH 7. Solution B, pH 10. So first, which one is more acidic? A, right? And actually, solution A is neutral because pH is 7. That's pure water. B is basic because it's bigger than 7. Okay, then I ask solution A has how many times more hydrogen than B? So the difference is 3. 3 is 10 multiplies 10 multiplies 10. So the answer is 1,000. Solution A actually has 1,000 times more hydrogen than B. Or you say solution B has 1,000 times less hydrogen than A. Both of them are correct. It's a log scale. So every time you change number by 1, it's 10. You change number by 2, it's 100. You change number by 3, is 1,000. Okay, so that's the most important thing you learn in this lecture. And in a body, pH is pretty important because in different body part, their pH could be totally different. So in your mouth, pH is about 7. in your stomach is very acidic. So pH is close to 1 to 2 because stomach acid is hydrochloric acid. So stomach is a very acidic environment. And in your small intestines, in the beginning of small intestines called the duodenum, is actually a basic environment. So the enzymes, their proteins help you to speed up the process of the chemical interaction. The enzyme in the mouth, amylase, that's the enzyme in the mouth, in the saliva, they actually prefer a pH 7 environment. So when you change the pH, when you go out too much, their activity decrease or even decrease to 0 because they are denatured. And the enzyme in the stomach, like pepsin, that's the enzyme digest peptides. Peptides are the proteins. They're actually like a very acidic environment. And enzymes work in the small intestines actually prefer a basic environment. So enzymes can only work at certain pH. We talk about protein denature. There are two ways to denature protein. One is temperature, and the second one is pH. So pH become very important in the human body. And when you learned AP1, you will learn homeostasis. Your body have a stable environment. So pH is also part of the homeostasis. You need to maintain the correct pH in your human body. So for Unit 2, the lecture stop here, means your exam 2 cover the materials till this part. And the next part will be the buffer. We will put it into Unit 3 materials. Okay, so let's stop here.